Okay, so good evening, everyone. Basically, we are just a couple of people, except as the professors. Buenas tardes a todos. Esta vez, lo mismo como las veces anteriores, tenemos profesor Frédéric Semé de Central Lille. Entonces vamos a hablar en inglés. So I will continue in English. So today's class is on network design and supply chain management. And Professor Frédéric Semé, thank you very much for accepting my invitation to join us today here. I will say a few words about Professor Semé. So he received his PhD from École Polytechnique Fédérale de Lausanne. He's full professor at Central Lille in France, and his main research activities are in the field of combinatorial optimization applied to location problems, transportation network design problems, and vehicle routing problems. These related problems are encountered from the strategic decision level to the operational decision level in transportation chain management. Professor Semé is and has been involved in various grant-funded and collaborative projects with transportation and logistics companies. He's currently the scientific leader of a project dedicated to urban distribution in the context of e-commerce and of a regional project on urban logistics. In addition, he is a member of the steering committees of the Verilog, which is Vehicle Routing and Logistics Group of the European Operational Research Society, Euro, of the group Groupe de Recherche en Recherche Opérationnelle, GDR-RO, of the CNRS, French National Research Council. And finally, he's, since 2015, Deputy Director of the Lille Research Center in Computer Science, Signal Automation, Crystal, gathering about 200 professors and researchers. Professor Semé has authored or co-authored more than 75 scientific papers or book chapters. His age index is 40, and he has been an associate editor, a member of the editorial board of Advances in Operations Research, Computers and Operations Research, and Infor. He received the President Medal of the British Operational Research Society in 1999 and was awarded the first prize for scientific contribution to the Euro ROADEV 2016 challenge. Frédéric, thank you very much once again, and please, the board is yours.
Thank you very much for those very kind words, Marine. So today my talk is about network design and supply chain management. And since you are maybe not so familiar with supply chain management, I will start by introducing supply chain management. I will just say a few words. I will talk a little bit about transportation, mainly freight transportation. And then in the second part of my lecture, I will introduce network design. We will see basic models which can be used for network design. I should say that I'm just attending a conference here in Spain, and so to Sevilla, and I just left a session devoted to network design and to issue in network design related to the climate change. In fact, in network design, what we have, or what we tend to have, is to define a network on which some flows, some goods, but you can imagine it could be telecommunication, and it could be also information are transferred from origin to destination. And this day, due to climate change, the thing is that this network is not so well defined. Routes can be blocked. Waterways, you can have problem related to the water level in waterways, and so on. For railways, you can have snowstorms. So there are issues related to the infrastructure. And so what you want to do is to design a network which is reliable. It's just exactly the same thing in terms of telecommunication. In fact, what you are interested in is to design a network, a telecommunication network, in such a way that if some link encounter issue problems, you can just have other paths to communicate with your colleagues, with your friends. Just think about telecommunication networks when you call with your cell phone. In fact, you are using an infrastructure, so a network, and sometimes you have issues on this network, and this is why the communication is not so good. So in fact, some part of the information is blocked, and this information does not reach your friend. So all these issues related to network design are quite important. They are important in day-to-day life, and we need some reliable networks nowadays to live. It's exactly the same thing in supply chain management. And I'm going to define all these terms. Just think about what we have in the industry. If you have troubles with the supply of products, of parts in a factory, everything is blocked. The factories uh, cannot produce those its products. So let me now, after those words, let me just introduce what is supply chain management. And supply chain management is related to something which is called logistics. Logistics is basically the discipline that studies the activities, determining the flow of materials and all the information related to those flows in a company from the origin to the destination. From the supply of the raw material to the delivery of finished product, and these logistics include as well the selling service, post-sale service. In fact, logistic is quite old. It's related to defense, to military. Before the Second World War, we know that logistic was quite important to guarantee the correct supply of troops. This is particularly true if you think about the big battles we experienced in Europe during this period. And the objective of logistic was to guarantee a correct supply in terms of victual, ammunition, and so on. During the Second World War, logistic somehow reached its peak. It was really an important issue because of poor logistic. People know, historians know that battles such as the Stalingrad battle was lost by the German army because the logistic just failed. So after the Second World War, there were a lot of logisticians who were on the market. They left the army, and they have to find a job. And what happened is basically they say, okay, we know about logistic. Let's try to use this knowledge in the civil in a civil environment, and that's why they try to develop those activities such as ensuring a correct purchasing, moving, and managing materials. Okay, I'm going to talk about logistic for manufacturing companies, and we are going to focus on this type of supply chain management in a moment. But I just want to mention that there are other logistics problems, mainly in service sectors. Just think about waste collection, electricity networks, distribution of service related to water, to gas, and so on. What is supply chain management? In fact, in supply chain management, we are going to have in an integrated view of the logistic. what we are going to do is we are going to consider all stages which are necessary to fulfill a customer request. So the basic things in terms of supply chain management, the basic person is the customer. It could be you and me, but it could be as well another company. So to satisfy this request, we are going to consider all the chain, all the different actors, which are manufacturers, supplier, carriers, uh, warehouses and their management, retailers, and so on. And when we are talking about supply chain, what we are talking about is about all functions which are involved in precisely fulfilling customer request. So these go beyond what I am going to present today. It it consists in product development, marketing operation, distribution. We are going to talk about network, so it will be related to distribution, finance, and customer service. So let me just to illustrate what I just said, let me just take a very simple example. Um, in fact, assume that a customer, you or me, we go to the supermarket to buy some type of detergent. So we go to the supermarket and we pick this bottle of detergent. But when we do this act, in fact, we generate something in a chain, and this chain can be described as follow. This bottle of detergent as follow a path or a set of paths I'm going to explain. Typically, the supermarket was supplied from a distribution center, which is DC. This distribution center was supplied from the detergent manufacturer, and this detergent manufacturer has a number of suppliers, which are the plastic producer, which are typically the packaging company, and also some chemical manufacturers, which which produce all the components of the detergent. But we can go a step beyond. If I take the plastic producer, he is supplied from some chemical manufacturer which produce sees the different components needed to produce plastic. And if you consider the packaging company, this packaging company is supplied by a paper manufacturer, and this paper manufacturer is supplied by some timber industry, and so on. So you have this chain, this very long chain from the supplier, which supply the raw materials, to the product producer, the detergent manufacturer, to the retailer, the supermarket, and finally to the customer. So what we are interested is to designing these type of things in supply chain management. So as I mentioned, and I insist on that, the customer is an integral part of the supply chain, since the customer generates the demand. Demand is generated by the customer. What we do in supply chain management, we are going to consider all the movement of products from supplier to manufacturers to distributors, but we will not only consider the physical products, but we are going to consider also the movement of information, the financial movements, and and for sure the physical movement. I mean the products movement. There are the supply chain can be decomposed in different stages. So we have customers, retailers, distributors, manufacturers, suppliers, and this can be represented through this picture. It comes from a book by Guiani, Laporte, and Musmano. So you see, you have these assembly plant, which could be called the producer. This is the producer, the manufacturer of the product. These on before this producer, you have the up supply chain, so which consists in the producers and which consists in suppliers and a company which produce a component which will be assembled in this plant. And then you have the downstream, so this is the upstream, and you have the downstream supply chain from this assembly plant to the final customers. And then you have all these stages. You can have a continental distribution center, and you can have regional distribution centers. Typically, a company has a number of continental distribution centers. Typically, you can have one or two in South America, two or three in Europe, and from these continental distribution centers, you just supply what is called regional distribution centers, and then from those centers you supply the customers or the retailer, the supermarkets, as I described before. So there are different type of flows. There is these downstream flows from the supplier to the customer, which is associated with the physical flow, the material flow. And then you have the finance flow. So the producers, the people who produce some the people who produce some money in this system, some wealth, are the consumer. And so you have an upstream flow, and then you have flow in both directions, which is the information flow. What is this information flow? If you buy something, if a consumer buys some product, this gives some information to the supermarket, and so on, and vice versa. If the supermarket receives some information from the production site, and so on. Okay, so there are different type of activities within the supply chain. You have the supply logistics, which is before carry out before the production plant. You have internal logistic. I'm not going to talk about this. It's all the logistics carry out in the production plant. And you have distribution logistic, which is carry out after the production. And what we are interested in today, talking about network design, will be about external logistic, which means logistic between which combines supply logistic and distribution logistics. Okay, there are different costs in logistics. I'm not going to into much detail on this. Let me just mention that We have different type of objective in the supply chain. It could be related to cost, to profit, or to service level. And in practice, in supply chain management and in logistics, people are mainly interested in costs and in service level. It's very difficult to measure the profits, what a good organization in terms of logistics will generate as profit. So a profit is usually not considered. So what we are going to consider here, it's a decision related to the structure of the supply chain. We are going to consider mainly how to transfer, how to distribute products from origin to destination. So this would be related to, this could be related to location decision, determination of the capacity of the facility. It could be related to which supplier, which plants we are going to use. And it's also related to the transportation mode. And all these questions are part of what we call strategic decision. These are long-term decisions, and those are also expensive decision. I will not talk about planning decision and neither about operational decision. Planning is to find the policies that are short term, what typically could be for the next year or for the next month, and the operational decisions are really related to the fact that we are considering the day-to-day strategy policies to manage the supply chain. Okay, so now let me, after this introduction, let me talk a little bit about network design. Just some numbers. These days, I put numbers for France, but it's true all over the world. Freight transportation is a crucial and important activity. Many companies are involved in transportation. I'm just talking about freight, not about person. Here you have the numbers for France. So it's about 79 billions of euros. It's about 3.5% of the GDP, but in fact, this is quite significant. During the last years, and this is changing. There was a great competition, mainly because we can serve more distant markets. In fact, what we have and what we experience, just thinking about China or Asia in general, you can produce products in large volume, not close to the market. We do not need to have the production sites close to the market. And then you can transfer products from these production locations to the market. This is going to change for different reasons. One is related to the climate change, and people try to produce product close to the sites, to the market. Another issue is due to the changing we can observe in terms of regulation. During many years, the markets were wide open. It could be, or it is not anymore totally the case right now. So countries change or are changing their policies, and they tend to close step by step their market. So this means that local production is encouraged, but let's say I don't want to be. It's not a course about the about the economy, but let's say that these type of arguments are changing, are evolving. What is combined in during the last years with these distance between the production sites and the market? Why this was possible? It was because transportation prices were very low. So we increase the size, the capacity of vehicles in the large sense, and the transportation costs were very low. Just to conclude on this, it's clear that e-commerce and all what the customer requires right now, e-commerce encourages transportation, and we know that in e-commerce transportation costs are very important. Okay, you have different type. I'm not going to go in all the details, but you have different type of transportation mode. What the main mode for freight is boat. So it's water. In fact, as you see, it's 99% in weight at the international level, 50% in terms of value. When I talking about water, it's seaboat, container, ship, and this type of things. This type of boat. The second transportation mode is rail. The picture varies quite a bit between Europe and North America, typically, because in Europe, the part of freight transportation for rail is relatively small, mainly because the rail companies favor the passengers. In United States, it's typically the reverse. Rail is for freight. If you go to US, or to Canada, you can see that those very long trains are just moving containers from one city to another one. Here is, let's say, really infrequent. People think that air is used. In fact, it is almost not used. Uh, Only high-value products are transported by airplanes. It's a big part in terms of value. It's a very low part in terms of volume. And finally, there are other modes such as airplane and also what is called intermodal modes, which mean that uh, you are going to use different type of transportation mode, not only one type to transport your goods. You can combine planes and trucks or train and trucks and so on. Okay, in terms of companies involved in transportation, you have two main. I will not go too much in these details, but there are two main actors, stakeholders. The first one is the shipper, and the second one is the carrier. The carrier, it's very simple. It's the company which is going to transport freight from origin to destination. And basically, just think about a trucking company. Have trucks. They have to determine between which terminals they are going to operate, at which frequency, with which type of terminal, what of vehicles, excuse me, what will be the number of vehicles they are going to manage, and so on. So it's really the carrier activities. What we are interested in right now, just talking about supply chain, is about the shipper. So what the shipper does, this is the party which requires movement of goods. So typically you produce, let's talk about the one company. I'm going to talk a big one like Coca-Cola. They produce Coca-Cola in their plants and they want to transport Coca-Cola, their bottles of Coca-Cola from those plants to the supermarket, and they would like to know how they are going to transport, which type of modes, which type they are going to use. For a given type of for a given transportation mode, they want to assign some shipment to these, so some pallets of Coca-Cola and so on. So these companies, they have to design the supply chain, how they are going to connect the plants to the continental distribution center, to the regional center, and so on. This is their work. The carriers, they are just going to say, okay, I'm going to pick up a number of pallets or a full truck of pallets in this plant and just transport them to this continental distribution center. So this is the simplest version we can look at. There are more complex version. They are what is called third-party logistics, but I'm not going in these details today. So what we are going to do now is we would like to just to look at those routing problems, transportation problems with large size demand. We are considering the supply chain, so I'm not interested in delivering small size demands, some parcels. No, and I'm interested in looking to the delivery of large quantities. So this is what we call national transportation service or international transportation service. There are all other type of transportation service. Typically, when you deliver grocery stores, which is called short haul transportation, or when you develop, if you look to the last mile delivery, what Amazon propose as services is what is called courier services, and this is typically what it's called again is short haul transportation. So what we are interested in what follow is this long haul transportation. Okay, so how do we model those transportation problem? Well, the objective is to determine a least cost routing over a network of transportation service from origin to destination. So let me just explain these words. Least cost routing for the freight, this is okay. Over transportation services, a network of transportation services, what is this network of transportation services? It's exactly we can have a connection with different carriers, and those carriers, they have each carrier has a network of transportation services. They go from A to B every Monday at 8 at noon and at 5 in the afternoon. And this is what they propose from A to B. And maybe they go from A to C, this company, every Tuesday and so on. And you have another company which also propose to go from A to B, but on Tuesday at 10 in the morning and at 4 in the afternoon, and so on. So this is this network of transportation service. There are two types of problem we can address. We can consider static problems and dynamic problems. Static problems, basically we are not considering the time. And in the dynamic problems, we are going to model the services over a time horizon. So let me just talk briefly about static traffic assignment models. This is not the type of model we use a lot, but I'm just going to show you, to explain a little bit. In fact, these models are modeled as a graph. You have the vertices which are associated with terminals, plants, warehouse. Think we are in the context of a supply chain. And you have those services which are proposed between the origin and the destination. So typically between A and B, I can go from A to B, and I have another service which goes from B to A. So the arcs are associated with the transportation services, and we would like to use this network or determine which type of services we are going to use in this network to deliver or to transport a number of commodities. So what is called a commodities is a product, a type of product or a family of product. If I'm interested uh, in grocery stores, if I'm managing a grocery store company, commodities can be frozen product, can be fruits, can be vegetables. So this is what we call commodities. And for each arc and each commodity, we have a cost and a capacity. So how much it costs to move some quantity of for a given commodity from A to B, and what is the capacity associated with this commodity. So that's for the static. For the dynamic, we are going to create what is called a time expanded direct graph. So we are going to take into account time. And what we are going to do, we are going to duplicate the nodes. So typically A, you have A at period 1, A at period 2, A at period 3, and the same thing for B, and the same thing for C. And see if I'm going back, I have a connection between A and B. Let us assume that it takes one period of time. So the product can leave A at period 1, and they will be in B at period 2. And they can leave A at period 2, and they will be in B at period 3. So this is what we call a service now from A to B. So this is a service which leaves A at a given period and arrives in B at a given period. For sure, a service can take more than one period. If it takes two periods going from A to C, we directly have an arc going from A to C, and it will take two periods. And we have these additional arcs. What are these additional arcs? In fact, those represent inventory. In fact, when you move along these arcs, the product doesn't move. It means that the product is stored for a given number of periods at a given location. So typically it is stored from one period, and it moves from A1 to A2. It is stored from one period in location A. So I'm just going to show you a small example. You can just look at this example later, but let me just show you very rapidly this example. In fact, we have a company and product which are delivered in Marseille from Africa. And the products are purchased from farmers and transport by sea to warehouses in Marseille. The goods are stored in refrigerated cells or at room temperature. And you can purchase products at different price. Those price vary according to the period of the year. And the company called Exo Fruit has to decide when and how much to buy. So how do we model this? In fact, if I move to the data, let me just consider the demand, the offer, excuse me. So no, I just miss it. This is what the supply and the demand. So what is it's the reverse. I made again the mistake. You see the demand and this the supply. So what is demand in Marseille at each period of time for each type of product? And the same thing, what is offered at each period of time for each type of product. We have two what is called macro products. The micro product depends on if the product are going to be stored in refrigerated cells or at room temperature. So that's the demand. That this is the supply at each period, and here you have the price. So if you price 1 ton of product one at period one, it goes 500 and so on. So you can represent this network, this problem as follow. In fact, you have two macro products, product one and product two. And you have the warehouse in Marseille, and you have the destination, the demand at for product one and for product two. And if you just look to the classical model, what you have is typically you can buy product one just for period one, and these are semester and deliver the product, and the same thing for product two. So this is the demand at period one. Or you can buy the product at period one. It will be in Marseille until period two, and satisfy the demand at period two. How do you model this problem? In fact, we model this problem as a linear problem. We have a set of origin, a set of destination. You have the supply, you have the demand, so the vertices associated with the supplies, the vertices associated with the demands. You have a capacity on each arc in general, generally speaking, and you have a cost associated with the arcs. And what you have flow variable, which is basically the quantity of product which goes from I to J in the graph. So the graph I consider is the graph which is modeled typically in the dynamic case, this type of graph. And I have two groups of constraints. So the variables should be positive. They are upper bounded. This is the capacity on the connection between I and J. And then you have flow variables. The flow variables which say the following. If it's an origin, if I is the origin, it says that the quantity which leaves I must be minus the quantity which arrives in I is equal to the supply in I. At the opposite, for demand node, the quantity which arrive minus the quantity which leave minus the quantity which arrives in I is equal to the demand. Again, for the supply node, it's the reverse. The quantity which leaves minus the quantity which arrives should be equal to the supply. And if you have a transfer node, just typically a logistic platform, what enters leaves. So the balance between what's leaving the node I and what arrives in node I, the balance should be equal to 0. So this is the basic model. This is called a single commodity. I'm just talking about one product. The model is linear. You have a linear cost function, and it's very easy to solve. You can have a more complex model, which is a multi-commodity model. So now we have different type of products. just talking about, I just mentioned for the exofruit case, we have two products, so we can model the problem for the different type of products. And in fact, the model is not more complex. In fact, you add an index related to the commodity. So you just add an index related to the commodity, and you have the cost if commodity K goes to from I to J per unit, so you minimize the total cost. You have those flow constraints, the same I just described before, but now you add the index related to the commodity. And then you can have two types of capacity constraints. You can have a capacity constraints related to the commodity, and you can have a global capacity constraint related to the whole set of commodities. Typically, for example, depending, you have to understand that there is some transportation mode going from I to J. On this transportation mode, for some type of product, you can have a capacity, and you have on the top of that, always on this connection between I and J, for this mode, you have a global capacity. So if I go back to my example, I'm going to have this type of model. I just represent again here the same graph, and you can just check by yourself the model. You have the capacity constraints depending on the quantity available and the demand. This constraint is related to the storage from period 1 to period 2. So you say, I let you check, but there is a maximum storage capacity in the warehouse in Marseille. And here you have the flow constraints. Basically, if typically I consider vertex 3, this is a transfer point. So the balance at this node, the balance is there, should be equal to 0. And you have exactly the same thing here for the this node, which represent the warehouse at period 2. The balance for this node should be equal to 0, is equal to 0. Finally, and I will conclude with this last model, we have what we call service network design problem. So it's about the same problem as before. In here, we have the frequency, but as I show you, frequency is related to the graph I define. We can add other features such as the number of stops and so on. And we can have also other constraints. Typically, we can have a constraint related to the operating rules at terminals and to the relocation of empty vehicles. Here, the most frequent case is the relocation of containers, because in practice, the freight flows are unbalanced. So you have full containers going from one origin to a destination, and empty containers going from the destination to the origin. The simplest model is the fixed charge network design model. I'm just going to show you what it is. In fact, if you look to what I have just presented before, it is again the same type of network design model. You have again for all commodities, for all vertices, those flow conservation constraints. You have, again, those capacity constraints per commodity. But here, if you look to the global capacity constraint for a given arc between I and j, you see that there is a new variable, which is yij. What means yij? It's basically a binary variable which is equal to 1 if we are going to use this connection. And why? Because in this service network design model, we are going to pay a cost to use this arc. You can say why we are going to pay to use this arc. In fact, you can imagine that just take the example of you see the arcs can be related to the storage of some containers in a given location, in a given terminal. So typically for these storage, you can pay a fixed cost plus a cost per container. So for these arcs associated with the storage of a container, you can pay a fixed cost plus some cost per container. So you have those fixed costs which appear. And in fact, here in these constraint, we just say that this capacity is available if this connect is open, if we can use arc ij, so if yij is equal to 1. So yij is equal to 0. If it's 0, the capacity is 0. So this sum is upper bounded by 0. So it's all the flows from I to j will be equal to 0. And if we open the connection, so we pay the price at the moment, we can use this capacity, and so the flow between I and j is upper bounded by the capacity of the R. So I think I am almost late because it's almost it's already 8. I just say to conclude, my last slide are devoted to a case study we did some years ago in France for an e-commerce company. And I just want to show you two things. Is basically we have a complex supply chain. You have the different village in France where you are going to transport parcels. You have those national distribution center. You have those regional distribution center, and you have the main warehouse of the company. And you have different type of vehicles. You use semi-trailers, then you use trucks, typical classical delivery trucks, and then you use vans. And you want that all in all, it takes at most 24 hours when you when a product leaves the national warehouse to this small village somewhere in France. So we developed a model. I'm not going to show the model. You have everything here. It's quite a complex model, but it's basically what I just showed you before. You have cost and constraints related to the capacities along these arcs, and we can design this type of things. You saw that in this case there are two national warehouses, one in Lille and one close to Paris, and from there we transport the parcel to those platforms, those terminals, and then to those little platform, which are called satellites. And from those satellites, the different villages are served. Okay, thank you very much for your attention. And if there is any question, I'm ready to answer those questions.
Thank you very much, Frederick, for this very interesting and broad talk that covers basically the supply chain management and the best of the supply chain management applied to infrastructures and AI in infrastructures. Luciana and Luis Antonio, do you have any questions? You have...
Hola, buenas tardes, no, para agradecer ahí, pues, la presentación, pues que muy chévere en el tema de la gestión y sobre todo ese tema que vimos en el transcurso de, de la maestría, como es el problema del flujo lineal de costo mínimo. Muy chévere ver un caso aplicado, ¿no? Y tener en cuenta todo, como todas esas variables que este ejercicio está como un poco más enriquecido, más detallado, más a la industria de lo que es lo real, ¿no? O sea, empiezan a ver como casos prácticos, muy chévere, me gustó mucho.
Bueno, profesor Seme ha respondido con un caso práctico, justo el último era el caso práctico, el modelo que han desarrollado para cubrir toda Francia con el suministro dentro de 24 horas. I will translate this to Professor Seme. So the comment was that thank you very much for this interesting talk, and the applications of the distribution network design in concrete cases. Basically, well, I said that you showed the example of France, but basically this is the mathematical programming and the optimization in supply chain management is used heavily, right? I mean, without the optimization people, without operations research people, there would be no supply chain management, basically. If you could comment that, Frederick, please.
Yes, nowadays I can tell you all big companies have very large groups who develop different type of methods for these problems. If you think Amazon has a very large group in US, in Seattle, and in Europe as well. I don't know about South America. I'm sorry, but they should have. And there is also if it's for passenger transportation, but Uber, for example, they have a very important groups of people working on those subjects. It's for passenger transportation. I think that yeah, as you can see, the role of transportation, and this is why I talk a little bit about the role of transportation in our society today, is so important. We are so dependent of products which for the moment at least are not produced close to where we live. The society is in this tendency right now, so we are dependent of those products, and on the other side, we need to have them as fast as possible. So the role of transportation for transportation goods is very important, and the only way to do it in an efficient way is to solve and to have methods which are able to solve those problems. I must say that most of these problems are not always well solved. This is not because of people are not and are not competent. This is mainly because those problems are very difficult to solve, and we have to find ways, tricks to solve them as efficiently as possible. Just to stick to what we are doing right now, there is something I do not talk about, but things I'm talking about supply chain management in general. There are a big impact of all those artificial intelligence method and the combination of artificial intelligence method within optimization methods. Mainly because many things are uncertain. Demand and are uncertain. The condition in which you can run the infrastructure is uncertain. So to face this uncertainty, those days we tend to try to apply to combine optimization and artificial intelligence in a smart way, or at least we try to do it.
Thank you very much, Frederick. Thank you very much for this interesting talk once again. If there are no more questions, so we finish the class for today.
Thank you.
Okay, thank you. Have a great evening.
Thank you.
Goodbye.
Bye-bye.